Hey guys, welcome back to another session of Senpai. And today we are going to be getting into that small topic called roots of equations. Now, I have actually been looking through quite a bit of past papers searching for questions like these because I know it's one of the topics that's going to be tested. And between the years 2020 going all the way down to 2016, I've only been able to find one. I'm not sure if my eyes may have missed it, but I only found one. So I thought today in this video, what I'll do is a short lesson on this topic as well as that past paper. It's singular. All right, it's just one question, but nonetheless, because it's coming, I would like you guys to have something you can go back to and review before you write your exam. All right, so going back to the very beginning, what exactly is the very beginning? Well, once upon a time, when you were in Form 4, perhaps Form 5, for some of you, your teachers would have introduced a topic called quadratics. And in doing quadratics, you would have learned that every quadratic has a standard form. Ax squared plus bx plus c. Now I'm going to write that as an equation, so I'm just going to put it equal to 0. Now, when you're doing basic quadratics, some things that you do need to know are how to factorize. So, for example, let's consider a question where we have, let's just x squared plus 5x plus 6. We'll go with positive numbers for the sake of simplicity. All right. And let's try to factorize this and see what happens. Well, in factorizing this, we will get, that's x plus 2 by x plus 3. And when you factorize quadratics, these two chunky brackets here, these are called your factors, in case you guys never realized. They have names. Factorization leads to factors. Okay, and when you get factors, you can actually set each factor equal to 0, and you can generate something called a root. So if I were to say set my first factor of x plus 2 being equal to 0, that implies that x has a value of negative 2. Similarly, if I set my second factor of x plus 3 being equal to 0, that implies that x is equal to negative 3. Now, these values here, these are actually called roots. All right, guys? So that is where your lesson comes from. It all began with quadratics. Now you know. All right, guys, so now let's try to see how we can incorporate this standard basic foundationary knowledge back into a little more complex situation. Okay, so let me just pause here and erase this screen. And we're back. So what I'm going to write at the top right hand corner here is our basic quadratic equation, ax squared plus bx plus c. And there's two things you should remember. That after you did quadratics, everyone should be able to recall two basic concepts, that the sum of your roots has a formula. Sum of your roots has a formula, and it goes like this. It's equal to negative b on a, as well as you have the product, right? The product of your roots. Remember what your roots are. After factorization, they're just those values of x. All right, so the product of your roots follows this little formula here, c over a. All right, so memorizing these two short products for quadratics should be very, very helpful when it comes to roots of equations involving, where you have alpha and beta, or should I say, the dreaded alpha and beta. Anywho's, let's get into it. All right, so let's consider a situation where we have a question and they're saying that an equation has roots alpha and beta. All right, so let me just write that down over here. Let's just say a question says that, we have an equation and the roots are alpha and beta. So then you tell yourself, I have no idea what that means. Well, not so. If you go back to what I did 2 minutes ago, once you have roots of an equation, you can use those roots, and in reverse, you can develop the factors of your equation. You see, using alpha, if alpha is a root, that should mean that x minus alpha would be a factor. Similarly, if beta is another root of your equation, that would also mean that x minus beta is a factor of your equation. And once you have your factors, you can actually multiply them to get your original equation. If I were to multiply these two factors, I would end up getting x squared minus beta x minus alpha x plus alpha beta. And then I could go on further to make this look a little bit I can factorize that x term out to get alpha plus beta x plus alpha beta. And this is where I really wanted us to get to, right? So we started from here. What if a question has roots alpha and beta? How do you now use those two values variables to get your original equation? Well, you simply create your factors. That's step one, right? You create your factors, and once you create your factors, you multiply them, and once you multiply them, you put them in the form x squared, x, and then your constant, and that's a quadratic format. Looking at this, what you can safely tell is that over here, you have your sum. You have your sum of your roots, because remember, both your roots were alpha and beta. So here we have alpha plus beta. That's the sum of your roots. All right. And finally over here, if you really think about it, that's also your product of your roots. All right, and using this new knowledge and tying it in with what we knew previously over here and here, what we can do now is safely equate, right? So what we are going to do is just a bit of equating. So I'm kind of trying to show you guys the proof of how it all came to be, all right? So what you can now deduce from both, right? For the basic quadratic, you knew you have two formulas here. And then using this roots thing, you can derive the sum of the roots and the product of the roots in terms of alpha and beta. And now, seeing that you have two types of expressions for the sum, you can simply equate and say that, hey, therefore, I know that the sum of my roots, which is alpha plus beta, is also equal to that cute formula, minus b on a. And by extension, you can also do that for the product of your roots. I think I'll put it on screen because I did say this is a small little lesson I'm trying to do within this past paper here, right? So the product of your roots, which is alpha, beta, is also going to be equal to C on A. And this, my friends, is what we use a lot. We use this knowledge a lot in being able to work questions that are of the form roots of equations. So let me try to bring up a past paper question, the only one I actually found, to show you guys how we can apply this simple knowledge into an actual question. So hang on, past paper question coming up next. Okay, so on screen, I had to go all the way till 2016, guys. Yes, 2016. Please leave a comment down below if you guys found more more recent year containing one of these questions. I don't know if it's the heat of the sun, but I completely did not find any except for 2016. All right, so let's see how we can hit up this question. So we're going. A quadratic equation is given by that standard quadratic, ax squared plus bx plus c equals 0. And immediately, once you get something like this, sum of your roots formula is supposed to pop up in the back of your head, minus b on a, and that product, all right, which is c on a. You should just have that to the side of your mind. Even if you need to use it in a question or not, just have it retained, all right? That's the trail you should be thinking along. Then you go on to read where A, B, and C are all elements of the set of real numbers. Okay, now these things are rather important, because I mean, sometimes when you work out values and you get imaginary values, this is where you know you can eliminate an answer if you have multiple answers. So some students tend to think this is just there for fun. It's not. It helps guide which is your correct answer. All right, so reading on, the complex roots of the equation are. So here's a key word. They're bringing complex numbers into roots of equations. They're merging them. So when you're talking complex roots, you're thinking, hey, something has to be imaginary, right? So they're saying the complex roots are, one of the roots is alpha, and one of our roots is beta. Now, they gave you values for alpha. They said that alpha is 1 minus 3i, and beta, well, we don't know the value of beta. But one thing that you should be able to recall is that complex roots, tell me before I write it, complex roots occur in conjugate pairs. All right, so if you did not have that previous knowledge, perhaps you may not have been able to move forward with this question. Once something occurs in conjugate pairs, it means that obviously by default, beta would be 1 plus 3i. All right, so that was an essential bit of knowledge that you needed to have in order to get that second root. Now, the question did not exactly ask us what is the value of beta. So before you get too excited, you have to read on to see what they're asking you, right? Now, the first part, they said calculate alpha plus beta and alpha beta. So they want the sum of the roots as well as the product. But because we actually have existing values for alpha and beta, we can do it rather straightforward. Hey, if they want alpha plus beta, we have the value. Alpha is 1 minus 3i, and beta is simply 1 plus 3i. Of course, these are going to cancel each other out such that we end up with just 2, because minus 3i is going to cancel with plus 3i. And there's that. Easy peasy. Now, the second part of that question, they also asked us to find the product, alpha beta, and 1 minus 3i by 1 plus 3i. There's actually a rule to remember how to do this, but if you don't, you'll have to expand using your FOIL method. That's fine, but it's simply going to be equal to 1 squared. You'll get that plus 3i, minus 3i is going to cancel out, and then finally you'll have minus, I'm sorry, there's just some dog action in the background, you know, barking incessantly. I don't know, they probably don't like maths, but anywho's. Right, so we're going to have 1 squared plus 3i minus 3i. That's going to cancel, and then minus 3 3s are 9i squared. Now, step to the side and recall that I squared is simply equal to minus 1. So therefore, this is going to be equal to 1 minus 9 by minus 1 is plus 9. You can work it out on your own time if you like. But there we have it. Those are the answers for part 1, alpha plus beta and alpha beta. So initially, to be honest, teaching this topic, as soon as I saw this and this, I started to think along the lines of this, which is why I wrote it down first, right? But we did not need to use it. The question took a different route from the moment we read the words complex roots, and we saw we actually had values, okay? So just be aware that when you are attempting these type of questions, all these things, all these train of thoughts should be in your mind when you're trying to attempt these types of questions, right? And all this knowledge should be there as well. So this one wasn't so bad. Now we have one last part of this question, a part 2. So let me just see if I could probably keep this on screen and bring that question just to the bottom here in case they are related. I don't really want to erase the screen. Okay, guys? All right, so on screen I have pulled up part 2. Let's get into it. So they're saying hence. So definitely we'll be using information from that previous part. So let's set it up. Hey, I remembered. Yay! Hence. Show that. So it's a proof as well, you know, hence show that. So they're asking us to prove that an equation having these roots is given by 10x squared plus 2x plus 1 equals 0 has roots 1 on alpha minus 2 comma 1 on beta minus 2. Okay, so set up some sort of statement if it's a hence and it's a proof, right? So let's go ahead and begin. Now they're saying in this question that it has roots as follows. So what I'm going to do is I'm simply going to write down my roots. My first root is given by 1 on alpha minus 2. And my second root is given by, so I'll write root. I should have written root, but that's okay. 1 on beta minus 2. Now, in order to complete this question, what you needed to recall is that bit of information we did at the very beginning of the question. And that information goes as follows. When you have your roots given in the form alpha and beta, and they tend to be a little more complex, you need to recall that your sum of your roots is also given by that formula minus b on a, and your product of your roots is given by the formula c on a. How exactly is this helpful? Well, it's very, very helpful because in the question above, if you go back, right, you will recognize that we had values for alpha plus beta and alpha beta, which we will need to use when eventually we have those types of expressions in our answer for this part. So let's see what happens here. Now, what is sum of the roots? Well, first of all, we have two roots here. So therefore, the sum, right, if you wanted to find the sum of those both roots will be given by 1 on alpha minus 2. So we're simply adding them, and 1 on beta minus 2. Now you need to do a little bit of LCM business here. You're going to get on your denominator, we're going to have to expand. We have no choice, right? So you're going to get alpha beta. All right, you're going to get alpha beta minus 2 alpha minus 2 beta plus 4 on your denominator. And on your numerator, we're going to get beta minus 2 plus alpha minus 2. Cleaning that up gives us, let's see, we're going to get alpha plus beta, let's put that in brackets, minus 4, and on our denominator, let's clean up, we're going to get alpha beta minus 2 into alpha plus beta plus 4. And what do you see? Aha! From previously, we found values for alpha plus beta, as well as we found values for alpha beta. From previously, I'll write it on the side here, we found that alpha plus beta is equal to a value of 1, I believe. Let's just go back and check. 2. It was 2, so let me write that on screen here. This is 2. And we also found that alpha beta, I am looking over here, alpha beta was equal to 10. So that's your hence in progress there. That is what we were expected to use from part 1. And then we are going to simply substitute these values everywhere we see them. So alpha beta here, we can replace this with 2. We have alpha plus beta here as well. We can replace that with 2. And then alpha beta, 10. And then you just go ahead, use a calculator, you get values for that. That's 10 plus 4 is 14, 14 minus 4, that's 10. So that works out to be minus 1 on 5. All right, cool. So besides this value being just minus 1 on 5, we also need to recall that this sum of your roots for any quadratic form is also given by minus b on a. All right, that is where that bit of information comes from. You want to have that essential knowledge lined up to be ready when you want to put it all together in your quadratic. Next step, after finding your sum, so the first thing you need to do is find your sum. Second thing we are going to do now is find our product of our roots based on what they gave us as the roots, all right? So the product of our roots will be as follows. It will simply be, let me just make this a little bit smaller, see if I have some space here. Yes, we do. All right. Product of our roots is simply going to be 1 on alpha minus 2 multiplied by 1 on beta minus 2. Let's go ahead and multiply those numerators. We'll get 1. On the bottom, if we multiply, we're essentially going to get the same as our denominator in the previous part, which is this piece over here. I'll underline it. And because we already have a numerical value, I'm just going to write that in as 10. All right, I'm not going to repeat the process because it's the same. All right, so now, besides the product of our roots being equal to 1 on 10, we also have to recall that if our sum of our roots is given by minus b on a, we should know also that the product of your roots is given by c on a. How exactly does that help us? Well, we need to remember that for any standard quadratic equation, if you're taking that format to be x squared minus your sum of your roots plus your product of your roots, then this value here and this value here has to be replaced by these values that you found. So your sum of your roots would be replaced with minus 1 on 5. So let's make that substitution. So we have x squared minus 1 on 5 plus your product of your roots. That's the value of 1 on 10. Now, the reason I did not write the form ax squared is because for this form, if you identify your formulas, it's given as minus b on a and c on a, which means that your a has been divided in your quadratic. It isn't there, right? So you have to recall that when you are trying to substitute back these values into a type of quadratic, the one you would be substituting it into is not one that a is in front of. You have to actually, what you need to do here is simply cross multiply so that you could get your value of a. And what we're going to cross multiply by across is 10 so that you have no denominator, and cross multiplying here throughout by 10. So I'm just going to say multiply across by 10. That's going to give us 10x squared. Minus by minus gives us a plus. And 10 over 5 gives us 2, so that's plus 2x, and then finally plus 1. And I think that's the equation they wanted us to get at the end. Let's just make sure it's 10x squared plus 2x plus 1 equals 0. Oh yes, I forgot to put my plus 0. Equals 0, sorry. So equals 0, and equals 0. And there you have it. That's it. We have used the roots they gave us in the questions. So let's just go through this one more time because there are essentially no more past papers I could find on this topic. So if in the event they give you roots right? It doesn't matter what the roots are. You need to find the sum of those two roots and the product. And you need to look around your question where you would have values of alpha plus beta or alpha beta and substitute those numerical values in order to get numerical values for the sum and product of your roots. Once you get those numerical values, you must be able to recall this. This is very, very important. I'd say one big mistake students make is over here. You see this sign, they write it as a plus. It is not supposed to be a plus. When you're substituting your sum and your products of your roots into here and here, whatever values they are, please remember that this sign in front of your sum is supposed to be a negative sign. All right, because you'll get your entire equation messed up. So once you're finished, you recall that you need to obviously cross multiply. That will help you get that value of a, your constant, your coefficient of your x squared too. And then you would really, really, truly have your equation in the form ax squared plus bx plus c. Okay, guys, so I hope that lesson as well as that past paper example helps you guys in event, not an event, questions like these are going to come, but pretty much this is as difficult as it would come, right? They're gonna give you two different roots. You just have to add them, multiply them, substitute values into them, and then just bring it all together into this formula highlighted in your purple box. And that's it. Easy peasy. So I wish you guys well. I do have one last video I may or may not make. It's on permutations and combinations. I mean, it tends to be an easy topic. I have requests to make it. If I be honest, it's not my favorite topic. But we'll see. Maybe I might surprise you guys, okay? But so far I'd safely say you guys have all the ammunition you need to get a excellent grade in your CAPE Pure Maths Unit 2. Alright, I have both lessons and past papers up. Just be sure to check the correct relevant playlist. I think most of my lessons are for module 2, but most of my past papers are for module 1. All right, so yeah, wherever your strength lies, just make sure you focus on those relevant playlists. I wish you guys all the best, and leave me a comment below if these videos have been helpful to you. It surely motivates me to make more. All right, and I'll see you guys again. Take care and bye.